In this segment, we're going to talk about secant method, and we'll go through the algorithm of the secant method. Secant method is used to find the roots of nonlinear equations. So we are again looking at finding the root of a nonlinear equation f of x equal to 0. And the secant method formula looks like this. X of I plus 1 is equal to x of I minus f of x of I times the difference between the two guesses, two estimates, divided by the value of the function x of I and the value of the function x of I minus 1. So let's go and see that how we can write down the algorithm for the secant method. So what we're going to do is, if you look at this particular formula here, what we do need is we need two initial guesses, x of I and x of I minus 1, to be able to get x of I plus 1. And then when we go through this process again, we'll have x of I and x of I plus 1, which we're going to use in this formula by increasing I by 1 and getting x of I plus 2. And that's how the whole process is going to work. So you always need two estimates of the guess. You're going to start with two initial guesses, but once you have once you've done the first iteration, then you need two estimates of the roots which are going to come out of using that formula. So let's write it down. So what I'm going to do is I'm going to choose I equal to 1. So I'm going to choose I equal to 1, and then what I'm going to do is I'm going to start with guesses x of I minus 1 and x of I. That's what I'm going to do. So in this case, when I is equal to 1, I'll have x naught and x1 as two initial guesses of the root itself. So I'll start with the initial guesses xi minus 1 and x of I. Then what I will do is I will use the formula. I'm going to use the formula that x of I plus 1 is equal to x of I minus f of xi times xi minus xi minus 1 divided by the value of the function x of I minus the value of the function x of I minus 1. So I'm going to use this formula, which is the secant method formula. So what I've done is I found x of I plus 1. But before I start using now the new estimate of the guess which I have obtained and one of the previous estimates which I have, I got to figure out what the relative approximate error is. So the fourth step which I need to do is I'm going to find absolute relative approximate error between the present approximation and the previous approximation. The present approximation is x of I plus 1. The previous approximation is x of I, and divided by x of I plus 1 times 100. And once I've calculated my absolute relative approximate error, which is the difference between the current approximation and the previous approximation, so once I've done that, what I'm going to do is I'm going to check if epsilon A, which is the absolute relative error, is it less than or equal to the pre-specified tolerance. So this is pre-specified tolerance. Now, pre-specified tolerance might be given to you as a percentage, or it might be given in terms of the number of significant digits you want to be at least correct in your answer. And those can be all translated into a percentage pre-specified tolerance. So if check if epsilon of the absolute relative approximate is less than the pre-specified tolerance. If true, then you stop because you have achieved your goal of getting your root within the pre-specified tolerance. If false, then what you need to go is you're going to go back to step 2. You're going to go back to step 2 with estimates x of I plus 1 and x of I. That's what you're going to do. You're going to basically go with the estimates of x of I plus 1 and x of I plus 1 which you just found, and x of I which you have from the previous iteration. That basically means that you are going with I is equal to I plus 1. That's what you got to think about, that you are now going to increment your I by 1. You're going to increment I by I plus 1, and that automatically knows that, hey, it has to take the new estimate which it found, x of I plus 1, and one of the previous estimates which you had in the right-hand side of the formula. And that's how the algorithm of this particular secant method is going to work. And that's the end of this segment.